So today we're going to be talking about the number system that we use, which is called base 10. What we're talking about when we say base 10 is that as we have our place values here, this is our ones place, and this is our tens place, and it goes on to hundreds and thousands as we move across this way. But as we fill up one place value, let's in this case our ones place, as we fill it up 10 times, we'll move that 10 over to the next place value and add 1 here. Another way to visualize this is, let's say that we have 14 ones here. Well, we can see that with 14 ones, we can represent this number as 14. However, with those 14 ones, we can group 10 of them into 110 and then count 10 plus 4 ones is the same thing as 14. This is 110. This is 4 ones. So let's take the number 4,786 for example. If I increase this number, I don't write the number that way. I take 10 of these ones and I transfer them over here into 110, which adds 1 to my tens place. So what I'm left with is 1 more in the tens place and no remaining ones. So let's look at this number, for example, 5,894. I want to break apart this number based on its different place values. For example, this 5 doesn't just mean 5, it means 5,000. And this 8 doesn't just mean 8, it means 800 because it's in the hundreds place. Same thing with this 9. It's not just 9, it's in the tens place, so it means 9 tens, which is 90. Now this 4 is in the ones place, so that just means 4. So if I look at this number broken up into its place values and read it going down this list, it should sound the exact same way as I read this number, 5,894, 5,894. So we can break apart numbers into powers of 10 by taking out zeros. So we could write this number 1,000 by taking out one of the zeros and multiplying what's left over, 100, times 10. 100 times 10 equals 1,000. And we can confirm that by looking at two things. First off, if I count the number of zeros in this multiplication problem, 1, 2, 3, that's the same number of zeros in the original number. And if I take the first number in both numbers of this multiplication problem and multiply them together, they should equal the first number in the original problem, which they do. 1 times 1 equals 1. Now I can also break this number into a different combination. I can take 2 zeros out and multiply what's left over, 10, times 100, and it's the same thing. Again, I count my zeros, 1, 2, 3, and I have 3 here. And then I multiply the first two numbers, 1 and 1, and they equal 1. I can do this one other way. Take the 3 zeros out and multiply by what's left over, 1, times 1,000. Again, we count the zeros, 1, 2, 3. There's 3 in the original number, and 1 times 1 is 1. We can break apart other numbers other than 1,000 doing the same strategy. So I'm going to take 1 0 out of here and break it down into a power of 10. So I'm going to be multiplying it by 10 or a power of 10, which would be 10, 100, 1,000, something like that. And since I took 1 0 out, I know that my next number needs to have 2 zeros so that they'll add up to the same number of zeros. And I know I'm going to be multiplying them. Then the only thing I need to check for is what number times this number is going to equal the first number here. Well, 1 times 4 is going to give me 4, so in this case I'm going to have 400 times 10 equals 4,000. And I can double check this by counting the zeros, 1, 2, 3, there's 3 there, and then multiplying the first number in both numbers of this multiplication problem. 4 times 1 is 4. I can do this the opposite way as well if I'm given a multiplication problem using a power of 10. Again, a power of 10 is going to be a number that starts with 1 and has a series of zeros after it. So if it has 1 0, then it's just 10, 2 zeros. It's still a power of 10. We've just multiplied 10 times 10. So in this case, again, I'm just going to count the zeros. Here I have 3 zeros, so I'm going to write those down. And then I multiply the first numbers in each number here. So 5 times 1, that's 5. There's my answer, 5,000. So we're also going to be talking about bar graphs today and how they can show us information in a visual format. So here I have a bar graph that shows the number of YouTube subscribers. We can use a bar graph like this to look for trends or relationships in a given set of data. So I want to point out what these two axes, that's what we call these lines here, axes represent. We can see the bottom one here represents the day. So day 1, day 2, day 3, day 4, day 5. And we're talking about the number of subscribers on each day. The reason we know that we're talking about the number of subscribers is this vertical axis is labeled number of subscribers. And we have a scale here that goes up by 5. Once we have our two axes labeled and the scale for them, now we can use those to look at the bits of information. So we can see on day 1 of this YouTube channel that it had 5 subscribers. That lines up. On day 2, it had a little less than 10, maybe 7 or 8. On day 3, it got up to around 10. Day 4, it dropped back down to about 7 or 8, and then day 5, it shot up to around 15. Having a visual representation of this information in a bar graph like this shows us a trend and a relationship that as the days went by, overall the number of subscribers increased. This also shows us that on day 4, we had a decrease, and we can see it clearly and quickly because it's represented visually in a bar graph. That's what bar graphs are helpful for.